This tutorial is for 5th grade, Module 1, Lesson 3a. The focus of this lesson is to look at powers of 10 and how we can write them using exponents. So for example, I have the number 10,000. I'm going to think of 10,000 as 10 times 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. This representation helps me write the number as an exponent. When I write this number as an exponent, I have a base of 10. The exponent is telling me how many times I multiplied 10 times 10. So I multiplied 4 tens to get 10,000. So that's my exponent. 10 to the 4th power means 10 times 10 times 10 times 10, or 10,000. I look at the next problem, 1,000. I can get 1,000 by multiplying 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So I multiplied 3 tens by each other. That's my clue for my exponent. How many tens did it take? 3. 10 times 10 times 10. So 1,000 is equal to 10 to the 3rd power. Here I have 10 times 10. Well, I know 10 times 10 is 100, but I can also express it as 10 to the 2nd power because I took 2 tens and multiplied them together. Over here, I have 100 times 100. So if I think 100 is 10 times 10, and then I have another 100, which is also 10 times 10. So I multiplied 4 tens together, so my exponent would be 10 to the 4th power. Here I have 1 million. If I think about 1 million, I can think of 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1 million. So I can count, I multiplied 10 6 times. So my exponent is 6. 10 to the 6th power is 1 million. To multiply 1,000 times 1,000, well, I know 1,000 is 10 times 10 times 10. Same with this one. 1,000 again is 10 times 10 times 10. So I also multiplied 6 tens together. So my base is 10 and my exponent is 6 as well. If we look back on the problems, we can see the pattern that develops. 10,000 has 4 zeros in it. When I express it in exponential form, my base is 10, my exponent is 4. 1,000 has 3 zeros in it, which means my exponent is 3. 10 to the 3rd power is 1,000. When I took 10 times 10, I had 2 zeros in the 10 times 10, and my exponent is 2. Multiplying 100 times 100, I see 4 zeros. My exponent is 4. So you can see how that pattern continues. That's a good way for students to check their answers. Do their zeros match the exponent? It's a good pattern to use when expressing numbers in exponential form. If we understand the pattern in exponents, it can help us with other multiplication problems. Here I have 9 times 10 to the 3rd power. Now we know that 10 to the 3rd power is 1,000. And we also know that when we multiply 9 times 1,000, the 9 shifts 3 place values to the left. So we see a pattern here. Shifting 3 place values to the left, I have an exponent of 3 as well. So 9 times 10 to the 3rd power is 9,000. 39 times 10 to the 4th power means my digits will shift 4 places to the left. And just like we saw the pattern before, because I have 4 as an exponent, I know I'm going to end up with 4 zeros in my number. So 39 times 10 to the 4th power is 390,000. Over here we're multiplying decimals by powers of 10. As we mentioned in previous lessons, we cannot just add zeros to the end of the number when multiplying by powers of 10, because that would result in an incorrect answer. We know that 10 to the 3rd power is the same thing as 1,000. So if I think I have 4 ones, I'm multiplying it by 1,000, that would result in 4,000, which follows the pattern of moving the digits 3 places to the right. So if I fill in the rest of my answer, 0 tenths resulted in 0 hundredths. I've moved it 3 places to the right. 2 hundredths resulted in 2 tens when we move it 3 places. And 5 thousandths results in 5 wholes when we moved it 3 places to the right. So 4 and 25 thousandths times 10 to the 3rd power is 4,025. Following the same example down here, now I'm multiplying by 10 to the 4th power, which happens to be 10,000. So 40 times 10,000 is 400,000. So I'm going to write the 4 and some empty place value holders so I can see how the digits shift. So now I have 0 that lands in the 10,000 spot. 2 tenths times 10,000 is 2,000. 5 hundredths times 10,000 is 500. And then I continue filling in the place value spots with zeros. So 40 and 25 hundredths times 10 to the 4th power is 402,500. Again, each digit moved 4 place value spots to the left. So there is another example of how the exponents can help us with multiplication problems.